previous system. So I will not take too much of time. So I'll start today's session. So good evening, everyone, and welcome to every participants. And today's guest is our Dr. Anirban Sarkar. And today we are in the third day of our faculty development program on multivariate data analysis and structural equation modeling using SPSS. And this program organized by Bharatiya Vidya Bhavan of Management Science, Kolkata, in association with SPSS and Indian Economic Association. And today's topic in the third day is Anova and Manova. And as I told you, today's resource person is Dr. Anirban Sarkar, who is professor and head of the Department of Commerce and Management in the West Bengal State University, Kolkata. Welcome you, sir, and thank you for association from the beginning to develop this program. And our principal sir is also present here and taking his permission. We are going to start today's session, sir. So you can start. Thank you.
Anirban sir, good evening.
Good evening.
Hope you're fine.
Yeah, I'm fine.
Hello.
Yeah, can you hear me?
Sir?
Can you hear me?
Yes, I can hear you, sir. Thank you so much for your valuable time and all support in our FDP. I can understand when Sudipta was telling, whatever you may say, it will be always less because you have really supported us in a wonderful way in this FDP. Thank you so much. Now, sir, it's on to you for your delivery.
Thank you. Hope to meet you soon.
Yes, absolutely.
Okay. So, good evening to all the participants. Today is the third day, I think, of this FDP, and I have been entrusted to give you orientation about Anova and Manova, analysis of variance, and multivariate analysis of variance. So let me start my session. I will be screen sharing my PPT as well as I will be writing little bit. So those please unmute and tell me that whether you can see the screen or not. And just to stabilize my net, I will switch off the video so that I can share the screen without any disturbance. And I will be showing you hands-on session because you know that the title of the FDP is Multivariate Data Analysis with SPSS. So we have collaborated with SPSS, and we will try to use SPSS and show you how Anova and Manova can be done with the help of SPSS and what will be their interpretations. In research, generally, we need to understand the context in which we will be using these techniques, when to use it, where to use it, how to use it, and after using it, what will be our interpretations on the results. I will be carrying on the session in a non-technical way as possible. I will be using less formulas because in any standard textbook, you will get all these Anova Manova formulas there. But our focus today will be on understanding the data sets and how to use SPSS to generate results in our research. For the theoretical background, I will touch a little bit, but in detail, if you want to understand the theory and the formulas and the derivation of the formulas, which SPSS will always do it for you. But to understand the theory, you may follow any standard statistical textbook like Gungupta, Dasgupta, and other textbooks are also there. So you can always go on and read those texts. So let us start with our session today. And I'm sharing my screen. Just at any point of time, due to internet issues, if you cannot hear me or cannot see my screen, just you can write in the chat or you can unmute and talk with me. Can you see my screen?
Yes, sir. Yes, sir.
Okay. So today our session will be on analysis of variance and multivariate analysis of variance. So in short, we call it as Manova. Here we call it as Anova. Now, basically, all these two techniques that we will talk about come under parametric test. Now, since the timing is very short, we have to cover up within 2 hours or less than 2 hours. So I will try to touch upon the theory in a minimum fashion as possible. Just I will express you the keywords. I will introduce you the keywords and try to explain those. So suppose if you get any data, this data will be measured on a scale. So when we are measuring data on a scale generally we call it as nominal data, ordinal data, interval data, and ratio scale data. So this interval and ratio, we call it as continuous data, or scale data. This nominal and ordinal part, we call it as categorical data or non-metric data. Here we call it as interval ratio, we call it as metric data. Now, the basic assumption behind this parametric test is that there are certain conditions or assumptions. We have certain conditions or assumptions that we need to check. Now, if these assumptions or conditions holds, we will be running parametric tests. If these conditions or assumption is violated, then we cannot use parametric test. We have to use the non-parametric test or the non-parametric equivalent of parametric test. So let us first understand what are the conditions or assumptions, and then we will go on to develop this parametric, that is analysis of variance and multivariate analysis of variance. So what are the conditions? The first condition is that your sample which you draw from the population should be unbiased. Sample should be unbiased. Means you have to randomly allocate the respondents or the participants. You have to randomly allocate. You cannot have bias in it. This is the first condition. Second condition is your data should be measured in interval or ratio scale. Now, interval or ratio scale, SPSS call it as a scale data. The third assumption is that your data should follow normal distribution. you have to check that whether your data is following normal distribution or not. There are certain tests. You can use box plot, you can use histogram to understand whether your data is following normal distribution or not. And another very important assumption or condition is homogeneity of variance. What is homogeneity of variance? That is equal variance assumed. What is equal variance? When you are drawing, say, two samples from two populations, you have to check whether the population variance is equal or not from which you are drawing the samples. If the population variance is equal, then we will say that homogeneity of variance assumption holds. And if all these conditions holds, we will be applying parametric test. Now, for one sample, we use different tests. For two samples, we use different tests. Generally, if your independent variable, I think all are accustomed with these two terms, dependent variable and independent variable, because in our research, we always try to identify that whether it is dependent variable or whether it is independent variable. How many independent variables are there? How many dependent variables are there in our research? And generally, when we are able to identify these dependent variables and independent variables, we call it as, in machine learning term, we call it as supervised learning. Supervised learning. And when we cannot identify the variables as independent or dependent, we apply unsupervised learning techniques. So here, if there is one dependent variable and if there is one independent variable with two conditions, we apply t-test. Now, you have to understand that in case of t-test, there may be two forms. One is independent measure, the other is repeated measure or paired t-test. If the participants are independent, we call it as an independent test. If the participants are repetitive, we call it as a repetitive measure test. So in case your participants are repetitive, we call it as a paired t-test in case of one independent variable with two conditions. Now, in research, we always find that there are more than two conditions. If there are more than two conditions of one independent variable, dependent variable is one. If dependent variable is one, if independent variable is one with two conditions, we apply t-test. If dependent variable is one, independent variable have more than two conditions, we apply analysis of variance. If there are more than one dependent variable, suppose you have two dependent variable and there may be 3, 4, any number of independent variables, we apply multivariate analysis of variance. So this should be very clear that if there is one dependent variable and one independent variable with two conditions, then we apply t-test. If there is one dependent variable and one independent variable with more than two conditions, we apply Anova. And if there are more than one dependent variable, we apply multivariate analysis of variance. So in a nutshell, this is clear to you?
Yes, sir.
Okay. So since SPSS has collaborated with us, so we have to give them weightage. So I will be using SPSS today in order to make you understand the topic that I have been given to, that is analysis of variance and multivariate analysis of variance. So just I will show you what will be the scenario or what will be the case. We will be solving some case studies here. And it will help you to understand the context in which we will be applying these techniques. So, and due to paucity of time, I will be show you the data set and I will run live. But if you want to practice later, I will share my PPT as well as my all data sets with the organizer. They can share it with you. So at your convenient time, you can practice with my data set. So my screen is visible?
Yes, sir.
Okay. So I have already mentioned that there are certain assumptions. If those assumptions, I have already written those assumptions. If those assumptions, if it holds, we call it as a parametric test. If those assumption does not hold, we call it as a non-parametric test. So in case of parametric test, there will be t-test, pair t-test, one-factor ANOVA, two-factor ANOVA. There may be MANOVA. In case of non-parametric equivalent, we can run Mann-Whitney test, Kruskal-Wallis test, Friedman test, Wilcoxon sign rank test. All these are non-parametric equivalent of parametric test if the conditions are violated. So just for you to understand, I have prepared this. Say you have one variable with two conditions. So if it is a independent, you know that in research design is very important. You have to understand your research design. Accordingly, you collect data and do the analysis. So if your design is independent type, independent measure type, then for parametric test, we run independent sample t-test. Now, if your design is repeated measure type, what is repeated measure? That same participants are being tested, same respondents are being tested. So then we call it as a related t-test or paired t-test. Suppose your parametric assumption is violated, then what to do? Then in case we have to go for the non-parametric equivalent. For non-parametric equivalent of independent sample t-test, we call it as a Mann-Whitney U. For non-parametric equivalent of paired t-test, we call Wilcoxon sign rank test. Similarly, you may have more than two conditions that I was talking. So if you have more than two conditions of your independent variable, you cannot run t-test anymore or non-parametric equivalent of that t-test anymore. Then what to do? If we have more than two conditions in our independent variable, then we run one factor ANOVA. So again, this concept comes, that is whether it is an independent measure or whether it is a repeated measure. If my participants are unique, if they are independent of each other, then we will run one factor independent measure ANOVA in case of independent variable with more than two conditions. And if my participants are common, if they are repetitive in nature, then we will run one factor repeated measure ANOVA. Again, I'm going back. You have to, first of all, you have to understand the conditions of or assumptions of this ANOVA or for that matter parametric test. If any of the condition is violated, then again we will go for non-parametric equivalent. So Kruskal-Wallis is a non-parametric equivalent of one factor independent measure ANOVA, and Friedman test is a non-parametric equivalent of one factor repeated measure ANOVA. So we will be focusing today on the parametric test. I will not talk about non-parametric. So in case of two independent variables, or for that matter, if you have more than two dependent variable or more than two dependent variable, we run MANOVA. I will come later. Here I have shown you that if there is more than one dependent variable, then we run MANOVA. It may be an independent measure MANOVA or a repeated measure MANOVA. I have already discussed what is independent measure and what is repeated measure. Now, in case of two independent variables, you may run two-factor ANOVA. Again, two-factor ANOVA may be a two-factor independent ANOVA. It may be a two-factor repeated ANOVA. And the third is two-factor mixed design ANOVA. Here, one independent variable is independent in nature and the other independent variable is repetitive in nature. So we are calling it as a mixed design, where one is independent, the other is repeated. So this is the context which we need to understand in order to run this ANOVA. It may be one factor, it may be two factor, it may be MANOVA. So I've already mentioned that the parametric assumptions is always you have to check whether it is ANOVA or a t-test or a MANOVA, the parametric assumptions you need to check. And the test statistic of ANOVA is the F-test. You know that if you go to any standard textbook, you will see that they will talk about sum of squares. Generally, we try to measure two things. One is the between group variation, the other is the within group variation. And sum of squares W, we call it as a within group variation, and sum of squares B, that is between, we call it a between variation. So if you let me write, it will be easier for you to understand then. Just I will show you that how we use these formulas. Formula you will get it in any standard textbook. Just let me write. Suppose let me start with F-test, because ANOVA we measure with the help of F-test. So the F-test value or the formula is MS, B is between, and MS, W, that is within group and between group. So what is MSB stands for? MSB, that is between mean sum of squares. We call it as sum of squares B by degrees of freedom B. Again, MSW, we call it as sum of squares W by degrees of freedom W. So this is the formula that we use, that is the F-test, and the formula looks like this. So I'm not going into details of this formula. If you go to any standard textbook, you will find this, that we may call it as SSW, that is sum of squares within sum of squares, between sum of squares is equal to total sum of squares. All these are elementary things. This you will get in any standard textbook. So I'm not wasting time here writing this. Any standard statistical textbook will give you all these formulas and the derivation of all these formulas. But our objective today is to show you hands-on with the data sets, that what data and how we will use those in our research. So without wasting time, just see this. ANOVA may be, I have already mentioned, it may be two types, one factor ANOVA and two factor ANOVA. One factor ANOVA may be independent measure ANOVA, repeated measure ANOVA. Two factor ANOVA similarly independent, repeated, and mixed design ANOVA. So let me go to the case first in order to make you understand. I think my screen is visible. My screen is visible?
Yes, sir.
Okay. So let us start with one factor independent, and gradually we will move one by one. This is the case study that we need to solve today. So just I am reading out for you. I will share the PPT, all these case studies and all the data sets with you at any point of time, at your convenient time. You can practice at your home. Just give a present hearing, patient hearing, and I will try to explain to the best of my ability. So suppose this is the case study here. A researcher was interested in the effects of a hint on a person's ability to solve anagrams. Anagrams, you know, as jumble of words. So the time it took a participant to solve 5 8-letter anagrams was measured. The same 5 anagrams were used in 3 conditions. That is, first letter, where the first letter of the word was given. So the hint was given, the first letter hint was given. Second is the last letter, where the last letter hint was given. And third is no letter, and no letter, where no help was given, no hint was given. So 30 participants were chosen and 10 were randomly allocated to each condition. The number of minutes it took to solve the 5 anagrams was, the 5 8-letter anagrams was recorded. So this is the scenario. Now, can you tell me that whether we will be applying here independent t-tests or a paired t-tests, or a one factor independent measure ANOVA, or a one factor repeated measure ANOVA? Please suggest, and why? Anybody, any scholar, you please unmute yourself and talk with me, because you know that classes, when we teach physically, we have eye contacts, we understand whether you are getting my point or not, but in a online perspective, it is little difficult unless otherwise you unmute and talk. So anybody, any guess or the logic behind? Are you all with me? Can you hear me? I am audible. Can you see my screen?
Yes, sir. It is audible. It is audible, and you can check the chat box. Actually, responding, you are getting response through the chat box.
Actually, in Zoom, this is very difficult to simultaneously check all this. Yeah, one factor ANOVA. Why? Please unmute and talk, because only chat one factor ANOVA does not give me a proper answer. What is the logic behind?
Hello, sir.
Yes.
Am I audible? Sir, I'm Shemonti Devroy.
Yes, madam.
Sir, I think because here the variable is time, we are measuring the time, the variation will happen in time. So that is the factor, and there are three different conditions. So we are measuring the time under three different conditions. That's why we are using one
Madam,
factor.
can you tell me what is the dependent variable and what is the independent variable in this case study? What is the dependent variable and what is the independent variable?
The variable we are measuring is time, sir. Time is
the time minutes, the number of minutes you are taking to solve the anagram. So that is the
number of
dependent. That is the dependent variable here. What is the independent variable?
The independent variable is the case that is given. That how many within a time, how much time, what the problem solving ability. That is the independent variable.
The type of the hints here. Actually, the type of hints. So why we cannot see the 30 participants were chosen and 10 were randomly allocated to each of these three conditions. So it is a case of independent measure. Participants are not being repetitive. So why it is?
Yes, sir.
Why we cannot handle it with t-test? Why we need ANOVA?
Sir, because there are more than two groups. That's why t-test is not applicable.
Correct, you are, madam. Actually, if we were given two hints, suppose first letter and last letter, we can apply t-test. Here, since there are more than two conditions, I have already mentioned that if there are more than two conditions, we cannot apply t-test. We have to handle it with ANOVA. That's why we are using one factor independent measure ANOVA. Very fine.
Yes.
Thank you. Okay. Now, so let us go to the data set now. Can you see the screen?
Yes, sir. Visible.
Yes, sir. Yes, sir.
Okay. So now you check the data set. I will tell you this. Already I have told you the story here. So the dependent variable here is the minutes and the independent variable is the type of hints. If you click here, you will get, I have written like this: 1 as first letter when first letter hint was given, 2 when last letter hint was given, and 3 no letter hint was given. I have been told that in the first class, all these variable view and data view of SPSS has been discussed with you. So I'm not repeating all this because time will be killed then. I'm just telling you the story behind the data set and how we interpret the data and how we type the data here. So here in values, we will be putting 1 for first letter, 2 for last letter, and 3 for no letter. You can put any number. I have put 1, 2, and 3 just to keep it simple. So now here check the type will be nominal scale. You will be getting 3 scales: scale, ordinal, and nominal. Scale means interval and ratio, and ordinal and nominal. So it will be a nominal scale data, and minutes will be recorded. It is a scale data. It is a interval data. So now if you check here, see, for first 10, first letter hint was given. For the next 10, last letter hint was given. And for the third batch, that is 21 to 30, no letter hint was given. And time in minutes was recorded to judge that how many minutes they have taken to solve the 5 anagrams, 8-letter anagram, 5 8-letter anagrams. So this is the case study now. So we will be solving it with the help of one factor independent measure ANOVA. So till now this is okay with you? Till now this is okay? Have you understood the case?
Yes.
So now we will go for analyzing the same. So this is easy, just go to analyze, go to general linear model. We have one independent variable with 3 conditions. So this is a univariate case. So we will click univariate. What is the dependent variable here? Which is the dependent variable? Minutes or type?
Minutes.
So we are putting minutes under dependent variable box and type under fixed factor box. You can follow me?
Yes, sir.
Okay. So
Yes.
I will send you the data sets. You can practice at your home. Now, what we will do, we will select options. In options, what we will do, we will choose the descriptive statistics. We may choose homogeneity test just to understand whether equal variance or not. And we will click continue. So here, if we want to check with the help of plots, then you can click plots as well. Plots type you can put under horizontal axis box. You just add it and click continue. Automatically plot will be generated. So click OK. Now check this results. Within a fraction of a second or minutes, result will be given. Now what you will do, you will double click all this, copy this and paste it in your Word file, all these tables, and you interpret. So I'm not doing that. I just showing you that just double clicking it and clicking the right click, you can copy and paste in your Word file. Now we need to interpret this. So my screen is visible, I think.
Yes.
Okay. So here, see, type we have 3 conditions, 1, 2, and 3. 1 is when first letter was given, 2 when last letter was given, and 3 when no letter was given. 10 participants in each for 3 conditions. Now come to the descriptive statistics. If you check the descriptive statistics here, you will get the mean time taken. See, when first letter hint was given, the mean time taken is 15. When the last letter hint was given, the mean time taken is 24. And when no letter or hint was given, the time taken was maximum, that is 28 minutes. So, and if you check the standard deviation, you will find that the spread of scores or spread of time maximum in case of no letter or no hint given, that is 4.397. Last letter little less, 3.464, and first letter very less, 2.944. So the spread of time taken is more in case of the variation is more in case when hints were not given. Now, just if you check the mean time, we can say that it is very easy to solve anagrams if the first letter hint was given because you are taking less time. And you are taking more time when last letter was given and a little more time when no hint was given. Now, descriptive statistics gives us the directionality of our data. So we have understood that what is the thing which is going on. Now we have to test it with the help of inferential statistics. Generally what happens is, you know that there are 3 types of statistics: descriptive statistics, illustrative statistics, and inferential statistics. Descriptive statistics means mean, standard deviation, range, skewness, kurtosis, all these things we need to check to understand the nature of our data set. And illustrative statistics is nothing but graphs, because graph speaks 1000 words. So if you can use graphs, it will be beneficial for you to make yourself and not only your examiners to understand that you have done it in a correct fashion. And the third is the inferential statistics, that is the significance test, whether the descriptive, whatever descriptive statistics is telling whether it is significant or not, that we test it with the help of inferential statistics. So here, this you can say it as a illustrative statistics, that is graph. This is test of between subject effects, we call it as a inferential statistics, is the ANOVA table. And assumption, Levine's test of equality of error variance, that is the homogeneity of variance assumption is being tested with the help of Levine. And descriptive statistics I have already mentioned. So now for the conditions you need to check, I was talking about homogeneity of variance assumption. Homogeneity of variance assumption says that if the F statistic is significant, then homogeneity of variance assumption fails. Means if it is less than 0.05, you know the p-value, the thumb rule of p-value is, if you are measuring at 95% confidence interval, we call it as a 0.05. And if we are measuring at 99% confidence interval, we call it as 0.01. So p-value, conservatively, we will be taking 0.05, that is 95% confidence interval. And we actually, what we do is, we check here that it is not significant. It is more than 0.05. So it means that since it is not significant, means our equality of variance assumption holds. If it would have been significant, means if it would have been less than 0.05, then we have to stop. Why? Because then our equality of variance assumption will be violated, means there is no equality of variance. Rather, the variation of the two population mean is different. So here we may confidently move forward. Why? Because the equality of variance assumption holds. Since it is not significant, it is greater than 0.05. This is the checking. Now, if you see the ANOVA table, if you check, we have type, error, total. So if you check the type here, it is significant. If you check the corrected model, it is also significant. R square, we are taking 71%. So 71% of variation is being explained with the help of this ANOVA model. So type you check, just check here. It is showing the F value is 33.250 and the significant value, it is less than 0.05. Not only that, it is less than 0.01 as well. So how we will write this in our thesis or research paper, how we write this. So let us go to the Word file again. Can you see this screen which I am erasing? Can you see it?
Yes, sir.
So the test result that we have got, how we will write that? What is the standard writing procedure? We will write here like this. F is the test statistic. In bracket, we will write degrees of freedom. What is our degrees of freedom? Just check. See. Type and error. Error 27. Type is 2. So we will write 2, 27 is equal to, what is the F value? What is the F value here? The F value is 33.250. So we will write 33.250, and which is less than the p value. We will tell as p is less than 0.05. Not only that, here the p value is also less than 0.01. But if we write this, that is enough. So what will be our conclusion then? What we will say? Can anybody tell me? What will be our conclusion? Just check the test result again. See here, first letter you are taking less time, last letter hint given more time, maximum time when no hint was given. Now, what will be your conclusion from this test statistic? What we will say?
Sir, Shemonti again, can I say?
Yes, yes.
So that is the time taken is not similar across the groups. There is a difference in the time taken. Means an alternate hypothesis. We are accepting the alternate hypothesis.
Basically, we will say that since our p-value is less than 0.05, it indicates that there is highly significant difference between the three groups. Okay.
Yes, yes.
Now,
yes.
We cannot say that where the significance lies. Now, we can say if we have run post hoc tests, post hoc multiple comparison tests, I'm coming now. Generally, what happens is you can say that there is significant difference. But where the significant difference lies, can you say from this result? You cannot say. We understand there is significant difference between the groups. I have deliberately not shown you. Now I will show. Again, go to analyze, go to general linear models, go to univariate. All things remain same. Just check post hoc. This post hoc test is essential. Why? In order to understand that there is significant difference in groups, but where this significance lies. So I am putting type here under post hoc test, and there are two tests which are very stable and balanced, Bonferroni and Taki, because these two tests, apart from all other tests, these two tests actually helps you to reduce your type 1 error. So there are two types of error, type 1 error and type 2 error. So if you want to reduce your type 1 error, which is very vital, you can check any of the two. Let me check Taki test. Click continue. Okay. Now see, all things remain same. You will get these two additional tables. Can you see these two additional tables? Can you see?
Yes.
Now check here. First letter belong to one group, last letter and no letter belong to another group. So there is significant difference between the first letter hint given and the last letter and no letter given. Here, last letter hint given and no letter hint given falls in one group. So if you check here the multiple comparison tests, you see if we compare first letter with last letter, it is significant. If you compare first letter with no letter, it is significant. But if you check last letter and no letter, you check it is not significant. It is slightly insignificant, greater than 0.05, but slightly. So on the basis of this table, this subsets has been created and it has been grouped into two subsets. One is the first letter and the other is last letter and no letter given. So now we are in a position to say that there is significant differences between groups, and rather there is significant difference between two groups here. One group where first letter hint was given and the other groups where last letter and no letter hint was given. So this is clear to you why we use this post hoc multiple comparison test, because you may get significant result, but you will not be able to tell where the significance lies. Only if you analyze with the help of post hoc comparison test, you will be able to pinpoint from where these differences are occurring. So this is clear to you?
Yes, sir. But I have a question, sir. This is Somnath Dutta.
Yes.
Then in case of our research paper or in case of thesis, this after the interpreting this Anova result, how we interpret this post hoc test results?
The way I am explaining it to you, similarly to write.
Okay.
That,
and both tables are required to give, or any one?
See, from this multiple comparison, this is Taki, honestly significant difference. You are getting that whether they are related or there is differences.
Okay.
From here.
Okay.
But these categorically groups into two two sets.
Okay.
If it would have been grouped into three, means first letter one group, last letter another group, no letter another group, then you can say that they are independent of each other. But here
Okay.
you can find from the result that last letter and no letter hint when given, they belong to one group.
Okay.
So this actually, this post hoc test give you penetrative results, which is very essential for going deep into your interpretation.
Okay. Okay. Sir. Okay.
Okay.
Okay. Sir.
Sir, my name is Anton Joseph. My question is, if the Levin's result is less than 0.05, how we will
Yeah.
solve the problem?
Means it is not significant. You cannot solve the problem. You will say that your test result is not significant. Means there is no significant differences among the groups. Generally, what you do, you form a null hypothesis and an alternative hypothesis. If you cannot reject your null hypothesis, you will accept your alternative hypothesis. As simple as that. Clear?
Sir,
Okay.
Sir, I have another question.
Yes.
Suppose, sir, this is very pertinent for our research to test this, but at the beginning, the Leibniz test homogeneity fails. Then what to do?
If your homogeneity variance assumption is violated, I have already mentioned in my initial understanding that you have to go for non-parametric test. You cannot apply parametric test. You cannot apply ANOVA. You have to go for non-parametric equivalent of ANOVA.
The Kurzweil we can use then.
Yes, you can use.
Sir, what is
Other
Welch
non-parametric.
statistics?
Yeah.
Welch statistics can be applied.
Welch test is another test which is you can apply for ANOVA. It is another test. Here SPSS will not give you Welch test. If you use R or if you use any other softwares like Jamovi, you will get the Welch test result. But I will focus on SPSS because SPSS is our official partner. I will talk on the basis of SPSS only. I will not talk any other things because otherwise they will be complaining to us. Okay. So we
Sir,
have to
in
be
that
very
post hoc part, we have two things are there. Equal variances are assumed. Equal variances are not assumed.
Here,
So,
equal variance assume you will take because your Levine test is showing you insignificant result, means your equality of variance assumption holds.
okay.
Clear?
But it is not assumed. There is option.
If it is significant, if it is less than 0.05, then your assumption is violated. Then you have to in that table you have to assume equal variance not assumed. Clear?
Then we have certain option there, like we have certain option there.
Please talk on the basis of the results which I am showing you. Don't talk on any other softwares. I am not allowed to talk. If it would have not been mentioned SPSS, then I could have given you answers. Okay.
Okay.
So this is clear to you, one factor independent measures ANOVA. When we use it, so in the initial writings, I have mentioned that one factor ANOVA may be of two types. One is independent measure, the other is repeated measure. So what is repeated measure? Can you see my screen?
Yes, sir.
Now we are coming to the repeated measure case. Just let us take another case study here. What is the case telling? A researcher program was set up to develop user-friendly computer equipment for people with physical disabilities. 3 new designs of computer keyboard for people with difficulties in hand and finger movement were developed and prototypes created. The researcher task is to decide which of these prototypes was the most successful. 4 potential users of the new equipment agreed to take part in the test of the new keyboards. Each participants were asked to use the keyboard to input a piece of text and the number of errors were recorded. 3 equally difficult pieces of text were used so that a participant did not improve performance by practice on the same piece of text. The choice of text and the order in which each subject tested the keyboards was controlled for to account for possible confounding variables. So here it is a case study that you have you are trying to launch keyboards for persons with physical disabilities in hand and finger movement, and you have called 4 physical disability person, and you are pre-testing your keyboards on those 4 persons, and you have launched 3 keyboards. Now you are giving them some piece of text and telling them to type on the with the help of the keyboards, and you are measuring how many errors they are incurring. So this is the case study. Now, if you see the variable view here, how many keyboards you are getting? 3 keyboards that we have talked about: keyboard 1, keyboard 2, and keyboard 3. How many persons were typing the text in these 3 keyboards? 4 persons. So you check here, how many rows are there? 4. So the same person is typing in keyboard 1, in keyboard 2, in keyboard 3. Likewise, 4 persons are using these 3 keyboards, and the errors are recorded. Now, can you tell me why we will be using a one-factor repeated measure ANOVA? Why it is not a case of one-factor independent measure ANOVA? Can anybody tell me?
Because the same user is applying on the 3 keyboards.
Yes, correct you are. I have mentioned that the same participants are being used for testing. So that's why it is a case of repeated measure ANOVA. Now, why it is a case of one-factor repeated measure ANOVA? Why you cannot handle with t-test, paired t-test?
Because 3 keyboards are there, more than 2.
Correct you are. So it has more than 2 conditions. So this is clear. The context of the data set is clear. Now we need to analyze it with the help of one-factor repeated measure ANOVA. So till now it is clear to you. If you have any doubt, you may ask me, or otherwise I will proceed. I will proceed.
Yes, sir.
Okay. So again, similarly, go to analyze, go to general linear model. Here, what we will choose, can anybody tell me? Under general linear model?
Third option, sir. Third lowest option.
Yes, correct. You are repeated measure. So here, we will give our factor name. What is that? Keyboard, or you may type just board, or you may type keyboard. How many levels are there for this keyboard? How many levels?
3 levels.
3, correct. So add, it will come. Now click define. Now you have to bring here one by one. Now what we will do? Now what we will do? If you want to check plots, you can do it. Board under horizontal axis, add, continue. We need to click options, same as the previous one. Board need to be brought under display means for. Now here in one-factor repeated measure ANOVA, if you want to check the post hoc test that I have shown you in case of one-factor independent measure ANOVA, here it is inbuilt. Here, if you check compare main effects and confidence interval adjustment, if you check Bonferroni, automatically they will give you the post hoc results. So here there is difference. You don't have to check it. If you check here in this option only, you will able to generate the post hoc test. So we need to check the descriptive statistics here. And we click continue, we click OK. See, pairwise comparison post hoc test has been given. So lots of result has been given. One by one we will interpret. Can you see the screen?
Yes, sir.
Now, first one is, okay, let me tell you one concept. Here, since it is a repeated measure case, another condition comes into the picture that we call as sphericity. We call it as a sphericity. What is this? Can anybody tell me what is sphericity? It is a condition which comes in a case in repeated measure case or repeated measure design. Have you heard of this term sphericity? Have you heard this? This is an assumption that we generally make when our data is a repeated measure design. Here you can see it is a repeated measure design case because the same participants are being tested on the 3 keyboards. So generally in case of ANOVA, I have already spoken to you about the homogeneity of variance assumption that we test it with the help of Levine's test. Here sphericity is actually nothing but homogeneity of covariance that we measure with the help of Moseley's tests. Moseley's test of sphericity. This is called homogeneity of covariance. Levine's test we use for homogeneity of variance. Another additional thing comes when we are going for repeated measure design, that is called the homogeneity of covariance. What is this? This is nothing but the homogeneity of variance of the differences between samples. Generally here we assume that the effect of independent variable will be consistent across both the conditions and the subject of the design that we are analyzing. So it should be consistent. So what does Moseley's test tells us? What is the condition here? That if you try to measure sphericity, that is homogeneity of covariance assumption, you measure with the help of Moseley's test, and Moseley's test result will always be significant. Means if there is homogeneity of covariance or equality of covariance, then similarly we have talked about Levine test, it should be non-significant. Here also it should be non-significant. Same here also Moseley's test should be non-significant. Non-significant means it should be greater than 0.05. Levine's test also I have mentioned it should be greater than 0.05 in order to be non-significant. Here also it should be greater than 0.05. And another check is the epsilon value. For sphericity, there are 2 checks. One is the epsilon value and the other is the Moseley's test. So Moseley's test, if it is non-significant, if it is greater than 0.05, and if your epsilon value tends to 1, then we may say that our sphericity assumption holds. This is the additional assumption in case of repeated measure. Sphericity problem don't come when you are using independent measure. There is no case of sphericity in case of independent measure. In repeated measure design, you have to understand that apart from the assumptions that I've already mentioned for homogeneity of variance through Levine test, another thing which comes is the sphericity problem. So sphericity is nothing but homogeneity of covariance, and it can be dealt with the help of Moseley's test and epsilon value. If your epsilon value is 10 to 1, and if your Moseley's test result is non-significant, then sphericity problem has been tackled. So assumption holds. So this is the theory behind. Now, if you go to the result, here check, we have 3 keyboards. The mean error, see, keyboard 1, 2, keyboard 2, 2, 4, keyboard 3, 6. Now, which keyboard, by just, this gives the directionality of your result. So descriptive, by just checking the descriptive statistics, suppose you are the manager who will take the decision to launch the keyboard. Now, which keyboard you should launch? Can anybody tell me? Keyboard 1, keyboard 2, or keyboard 3? Just seeing the descriptive statistics result. Which keyboard should be launched by the company?
Keyboard 1, because mean error is less, spread is also less.
Perfect, perfect, you are. So since keyboard 1 gives the less number of errors, so keyboard 1 should be launched. Now, it is just showing the directionality of the result. We have to check the significance with the help of Anova test. I am coming later. Multivariate test, if multivariate test only we will interpret if our sphericity problem holds. Means if we cannot tackle the sphericity problem, if your Moseley's test result is significant or your epsilon value is not tending to 1, then you reject your Anova, you go for multivariate test table interpretation. Now, first we will omit this if we see that our sphericity problem has been eradicated. Now check here, see Moseley's W that I was talking about, it is significant. See 1.0 means it is greater than 0.05, means sphericity problem is not there. Not only that, if you check the epsilon value, there is greenhouse geyser epsilon value, Hunefeld epsilon value, all are tending to 1, exactly 1. Means there is no sphericity problem in our data. This assumption holds. So we do no need to interpret multivariate test table. Rather, we will be interpreting our Anova test table. So here, since our sphericity assumption holds, this is the Anova table, and we will interpret in this fashion. See, sphericity, I assume this row we will take because our sphericity assumption holds. What is the F value? 16. What is the degree of freedom? 2 and 6. Whether our result is significant, it is less than 0.05. So how we write again, what we will be writing here? F 2, 6 is equal to 2 is the degrees of freedom, 2 and 6 is equal to 16. F value is 16. So we will write 16. P value is less than 0.05. So can anybody interpret? Can anybody interpret this? Since our P value is less than 0.05, means it is significant. This indicates that there is a significant difference among the performance of the keyboards. We have 3 keyboards. Now, post hoc test result will show where actually the difference lies. Now, here you will get this post hoc result. See here, this post hoc result has been given. So, see here, see the significance column. If you compare 1 and 2, it is not significant. 1 and 3, it is significant. So there is significant differences between 1 and 3 keyboard. But for 2 and 3, if you check 2 and 1, not significant, 2 and 3, not significant. But there is huge difference between 1 and 3. Why? Because we have seen here from the descriptive statistics, they see there is huge difference between keyboard 1 and keyboard 3. Now, where the difference lies, which we can understand from this pairwise comment, that is the post hoc test. So there is significant differences among the keyboards, and more so there is differences among keyboard 1 and keyboard 3, and we will be launching keyboard 1. Why? Because the error is minimum while using keyboard 1. This is clear? This is clear to you? Any question you may ask me? If you have any question, you can ask me. So only in case of repeated measure, this sphericity table is very important, because you have to check this sphericity assumption, whether it holds or not. If it is violated, then you cannot run ANOVA. You have to go for non-parametric test. So I will proceed. If you have anything to ask, you may ask, or otherwise I will proceed. So I have completed the one factor independent and repeated measure ANOVA. So now you will be conversant with this. So you can handle two factor as well as MANOVA. All these results are more or less, the tables are same. I will show you. So let us go for two factor ANOVA. Can you see the screen?
Sir, it's visible.
See, independent and repeated measure, now I think it is clear to you. So whether it is a one factor or two factor, the process will be same. You need to understand that whether it is a independent measure case or a repeated measure case on the basis of the respondent that is being involved. So here, just check the case study for the two factor independent measure ANOVA. An expanding company wanted to know how to introduce a new type of machine into the factory. Should it transfer staff working on the old machine to operate it, or employ new staff who had not worked on any machine before? A researcher selected 12 staff who had experience to the old machine, and 12 staff who had no such experience. Half the participants from each group were allocated to the new machine and half to the old machine. The number of errors made by the participants over a set period was measured. So the company is trying to expand and they want to introduce new machines. They have old workers and they have hired new workers as well. So here 24 workers have been studied. 12 belong to the old category and 12 belong to the new category. And on the old machine, some persons were allocated, and on the new machines, some persons were allocated. Some means 12 equally. 24 persons, 12 for old machine, 12 for new machine, and the errors were recorded. So now if you come to the data set, you will be able to understand. See here, there is staff, there is machine, and there is error. Which is the dependent variable here? Can anybody tell me? Which is the dependent variable? Which is the dependent variable?
The errors made.
Yes,
by the
error is the
workers.
dependent variable. And how many independent variables are there?
The machines, the types of machines are there.
Machines and staff. These are two
New and
independent
old.
variables. Now, if it
Yes,
would have been one independent variable, it would have been one factor ANOVA. Since there are two independent variables, we will be running Two-factor ANOVA. This is clear?
Yes.
Now, staff, there are two types of staff. One is novice and the other is experienced. Means novice means new and experience means old. Similarly, we have machines. There are two levels of machines. One is old machine, the other is new machine. So this is clear. Now you check 12 novice means new staff allocated, 12 experienced staff allocated, total 24, and 6 new staff have been given old machine, 6 new staff have been given new machine. Similarly, 6 old staff has been given old machine and 6 old staff has been given new machine. So it is a balanced design, which we call it as a research design. This is a balanced design, equally allocated, and errors were recorded. How many errors they have made on working on the machine, it has been recorded. So this is clear to you. Can anybody
Yes,
say why it is a case of two-factor independent measure? Why it is not a case of a one-factor measure or independent or repeated measure? Why? How we can understand? What is the logic?
Because the one factor is working on one machine only. So that is why it is independent, not repeated. And there are two kinds of workers and two kinds of machines. So that's why two-factor it is becoming.
Yeah. So 2 independent variables with 2 levels and 1 dependent variable. That's why we are using two-factor. If it would have been 1 independent variable with 2 levels, we would have used 1 factor. Clear? This is clear to you? So,
Yes, sir.
so now go to analyze. Same general linear model. What we will use here? This is an independent measure case or a repeated measure case?
Independent.
So univariate.
Bivariate.
So error is the dependent variable here.
Yes, sir. Error is the dependent.
Bring it under dependent variable box. I will request all the participants to mute yourself. Only if you need to talk with me, unmute and talk. Otherwise, please mute yourself. Surrounding sound is coming. And under fixed factor, we have to bring these two. That is staff and machine under fixed factor. Again, similarly, we have to go to options. What we will do, we will click the descriptive statistics. We know we don't need to use this post hoc comparison test here. Why? Can anybody tell me why we don't need to do this here? Just I'm telling you the checkpoint. Please note it. If you have independent variable with 2 levels, there is no problem of this post hoc test. You don't need to understand it. Result will be very much okay. Only if you have independent variables with more than 2 conditions, like we were having first letter hint, last letter hint, no letter hint, 3 conditions, then only we use post hoc test. If the level is 2, we don't need to use post hoc test. If it is more than 2 levels for independent variables, we use this post hoc test. Here you see for the staff, it is 2 level. For machine also, it is 2 level. So no need to use this post hoc test. Only descriptive test is okay. And we can check the plots as well. You can put staff under horizontal axis, machine under separate lines, click add, click continue, and click OK. Check the result. We have allocated 12 staff, 12 novice or new staff, 12 experienced staff. We have used 12 old machines and 12 new machines in our study. The descriptive statistic result, can anybody interpret? I have shown you how to interpret. Can anybody interpret this descriptive statistic for me? If you understand one ANOVA, you can interpret many. Can anybody interpret this descriptive statistics table? No volunteer. Nobody.
So I think it means that those who were the new workers, in the old kind of machine, the mean number of errors was 5, whereas in the new machine, 5.8, whereas in the new kind of machine, the mean error was 5.5. SD was also high in the new old machine, but SD is low. So variation is low in the new kind of machine for the novice workers. And for the inexperienced workers, their error was much lower in the old machine, but much higher error in the new machine. Those who are experienced, when experienced with the old kind of machine, they are more used to it. So they are making less errors on the old machine, but they are making more errors on the new machine.
Yes, means they have since they have handled the old machine, so their error is less. But since they are new to the new machine, their error is more.
They are making more errors.
But for the new staff, more or less, old machine, new machines, the error is same, more or less same.
Average errors are same.
Yes, yes. This is the interpretation. Now we can the ANOVA result we can write in this same fashions which I have already mentioned. That is the first one. Let us see the first one here. First one, see this. The first one is FS. For staff, it is 1.667, and 1 and 20 is the degrees of freedom. So we write here like this. F for staff, we will write F is 120, that is the degree of freedom, and the result is 1.667. It is not significant. See, 0.211 greater than 0.05, it is not significant. So 1.667. 1.667. P value is greater than 0.05. This is for staff, the main effect. For machine, we need to write it separately. What is the machine result? It is given. For machine C, 48.167, it is significant. For 53.519, if statistic result is 53.519, it is significant. So we write for machine same, F degrees of freedom is same. We write 53.519 and the P value is less than 0.05. So here it is significant. Here it is not significant. And what is the interaction effect? Why? Because these are two main effects, staff and machine. What is the interaction effect? We check. See, staff and machine interaction effect is, it is also significant, 66.852. So we write again for the interaction effect, that is staff into machine, F120 is equal to, what is the result? 66.852. 66.852. P value is less than 0.05, means it is significant. So what we will say, what will be our interpretation? For staff, we have not found any significant main effect. For machines, we have found the significant main effect, that whether they are using old machine or new machine, it has an impact. And for the interaction also between two factors, that is staff and machine, the result is significant. So this is how we interpret. So this is clear to you? This is clear?
Yes, sir.
So let us now go for the two-factor repeated measure design. Now check this case study again. This I have developed to make you understand the two-factor repeated measure design. Repeated measure means again the sphericity problem, that assumption we need to check. Here it will be little much complex because here there are two independent variables. Now check here. In a factory, a machine produces two kinds of product. One that requires the operator to follow a complex set of instructions, and one that is very simple to make. Means there are two types of instruction, one complex instruction and the simple instruction. There are two shifts in the factory, a day shift and a night shift. The factory manager wants the factory to make the products with the minimum of errors, minimum number of errors. A researcher decides to study the effect of shift, that is whether day shift or night shift, and the product, whether complex product or simple product, or complex instruction or simple instruction, on the errors made by the operators. All operators work both shifts on a rotation system. 6 operators are randomly selected and their error performance is measured during a day shift and a night shift. Appropriate balancing is undertaken so that testing 3 operators on the day shift first and 3 on the night shift first controls for carryover effects from one shift to another. So there are 6 operators you are testing. 3 of them you have given a day shift first and 3 night shift, and then again you have rotated them. So this is the case study. So let us check the data now. So check, this is day shift complex product, day shift simple product, night shift complex product, and night shift simple product. So just check. Day shift complex product, day shift simple product, night shift complex product, night shift simple product. How many operators? 6 operators are being tested. And the errors were recorded. Now tell me which statistical technique you should use here in order to understand that whether there is effect on the performance of the operators on the basis of shift or on the basis of products.
So basis of shift.
No, I'm telling you what analysis you should do. And why?
Sir, I think multivariate ANOVA.
Why?
Because there are more than one dependent variable. There are
What?
2 dependent variables.
What are the 2 dependent variables here?
One is the type of the product, the complex and simple, and one is the time, that is day shift and night shift. 2 shifts and 2 types of products.
Madam, you check this case study again. Here, there is only one dependent variable, that is the errors. You are recording the errors only. And there are 2 independent variables. One is the product itself.
One is time of the day. Huh?
Yeah, and the other is shift. So one is shift with 2 conditions, day and night. Other is the product with 2 conditions, complex and simple. So here it is a 2-factor repeated measure ANOVA. Why? Because here one dependent variable, that is the errors, and two independent variable with two levels. One is shift and the other is product. Clear?
Okay. Okay. Yes, sir. Yes, sir.
Now, why repeated measure? Can you tell me by seeing the data? Why it is a repeated measure?
Because, sir, the same group, same 6 persons are 2 times being used. One for old machine as for simple product, as well as complex product, as well as for the 2 different type of shifts.
Yes, yes, perfect. You are. Thank you. So now, since we have understood what to do, understanding the data set, now we will run the analysis. Go to analysis, go to general linear model. What we should choose here? What we should choose?
Repeated measures.
Yes, repeated measures. So, repeated measures. And here we have what we have.
One is shift, sir, and another one is type of product.
So what we will write here? First, we will write shift. How many levels for shift?
2 levels.
2 levels. Add. Again, we will write product. I will request others to please mute. Sound is coming. Product, how many levels for product?
Also 2.
2. Good. Product means complex and simple. Shift means day and night. Now click define. Now we have to match it. So first is day com. Day, shift and complex product. 1, 1. Bring it. Next is day and simple product. Day and simple product. 1, 2. Bring it. Next is night com. Night, shift and complex product. Bring it. Next is night and simple product. Bring it. So we have brought all the variables now. Now what to do? Go to options. What you will do here? There is need to do the Bonferroni test or pairwise comparison test. Anybody?
No, sir, not required because level is 2 in for
Yes.
both.
Perfect. Perfect. You are. Since there is only 2 levels, we don't need to check the post hoc test. If it would have been more than 2 levels, we would have checked it. So only descriptive statistics will suffice. Click continue. Now, if you want to check the plots, already I have told you, shift bring under horizontal axis, product bring under separate lines, add it and continue. And if you click OK, you will get the results now. See, multivariate test table, we will not interpret. First, we need to check the Mosley's test of sphericity. And then if it holds, then we will continue with ANOVA. If it is violated, then we will go to multivariate test table. Then ANOVA will be rejected. So first, understand there are 2 products and 2 shifts. This has been given here. Now check the descriptive statistics. You will get a directionality of your result. Can anybody interpret this descriptive statistic? Can anybody interpret this descriptive statistics? See here, during daytime, the error is less than during night time. If you check the day and night, daytime when you are producing simple products, your mean error is 3.67. When you are producing that simple product at night time, your error is more. Again, if you compare day and night with a complex product, see, when you are producing complex product during day, your error is 5.5, but at night it is much higher. So we may say that when you are producing during daytime, your error is less than when you are producing during night time. Similarly, when you are producing simple product, your error is less. When you are producing complex product, your error is more. Now check the Mosley's test of sphericity. I am not repeating this because you know that this is the homogeneity of covariance assumption. We have to check the significant column. C dot given means no result has been given, means Mosley's test of sphericity problem does not arise at all. If you check the epsilon value, all are equal to 1, means our sphericity problem has been handled here. So the assumption is not violated. So we may proceed towards interpreting our ANOVA table, and then sphericity assumed table we will interpret. Now, how we will interpret, I'm coming one by one. Just check this table and we will write in the same fashion that we have written with the help of the F statistic. So what I should write first, can anybody tell me? Similar things being repeated here. The first factor is shift. See here 35.714 significant. So how I will write? I will write, let me erase this. We will write for the shift, we will write F, the degrees of freedom is 1 and 5 is equal to degrees of freedom is 1 and 5. F value is 35.714. 35.714, and it is less than 0.05. It is significant. Similarly, for product, we have to check. F15, it will be remain same. F15 for product, it is 78.478. It is also significant. 78.478. 78.478. P value is less than 0.05. It is also significant. And what is the, these are the main effect. We call it as a main effect. Shift and product. These are two independent variables. And what is the interaction effect? Interaction effect between two. Interaction effect between shift and product. Shift and product. Again, we have to write if the degrees of freedom will remain same. So if statistics will change, F for shift and product check 7.273, it is less than 0.05. It is also significant. 7.273. 7.273. P value is less than 0.05. It is also significant. So how we will interpret? We will interpret that both the shift and the product have an effect on the number of errors being made. So both are significant. So shift have a influence or role to play on the errors. Product also have a role to play on the errors being made. So it is being influenced. So significant. So this is how we interpret the data. Now, significant difference means from the descriptive statistics, we have already seen that the participants have made, if you check the descriptive statistics, the participants have made more errors on the night shift than on the day shift. And particularly this is true when you are dealing with the complex products. So this is how we interpret. So this is clear to you, this two-factor independent and repeated measure ANOVA.
Yes, sir.
Just I will show you a Manova thing. Manova means nothing. It is same only if it is more than one dependent variable, we run the Manova. Because if it is one dependent variable, if there is one independent variable, we want one factor ANOVA. If it is one independent variable, if it is one dependent variable and two independent variable with two or more conditions, we run two factor ANOVA. But here we have more than one dependent variable. So if there is more than one dependent variable, we cannot use ANOVA anymore. You have to use MANOVA. So just check here. This is a MANOVA case, independent measure and repeated measure. Yeah, till now, I think you have understood what is independent measure and repeated measure. Just take this case study. Here it will be a two dependent variable case. See, a researcher wanted to evaluate a new teaching method to improve students' performance on English and mathematics. Two schools were selected to participate in this study, a traditional school and a newly built school. The newly built school offered to pilot the new teaching method, while the traditional school continued with existing teaching methods. Math scores were measured on a scale out of 100 and English on a scale out of 60. So if you now check the data set here, now check the variable view first. We have school, two types of school. One is the new school and the second is the traditional school. We have two subjects, English and maths. Now, just check this data set now. So English, the result is out of 60 and maths, the result is out of 100. So 20 students, 10 new school and 10 traditional school, they have given tests and the marks has been recorded. Now, can anybody tell me why you will not run ANOVA, but you will run MANOVA here? And why it is not independent measure, but it is not a repeated measure, it is an independent measure case? Can anybody tell me?
So it is not repeated because here every time the sample respondents, I mean the students are different from each different schools.
Yes.
And it is MANOVA because there are number of dependent variable is two, because two type of scores we are measuring, one for each subject in mathematics and English.
And what is the grouping variable here?
Group variable by
school.
Yes, school.
Just I want you to make yourself understand that keep it in mind, when it is a repeated measure scale, there will be no grouping variable. But when it is an independent measure case, always there will be a grouping variable. So here it is an independent measure case and the grouping variable is the school. And the marks on English and maths, so two dependent variable here, English and maths scores. So since it is more than one dependent variable, two dependent variable, English and maths, so we are running MANOVA, not ANOVA, because if your dependent variable is more than one, you cannot handle it with ANOVA, you have to go for MANOVA. Clear? The data set is clear?
Yes.
So now we go to analyze general linear model. What we will choose here?
So multivariate.
Multivariance.
Perfect. Multivariate. How many dependent variable here?
2.
English and
Maths.
so bring it under dependent variable box. Fixed factor is the school. Go to options. Descriptive statistics. Now tell me, do you need to go for post hoc test?
No, sir.
Why?
Because here also level is 2.
Perfect. So just descriptive statistics, and if you want to take the homogeneity or that is Levine test, you can click homogeneity test. So continue. Any other thing you need to check? Post hoc we don't need. So click OK. See here. Two type of school, new school and traditional school, 10 students each. Check the descriptive statistics. You will get the directionality of your result. See, in case of English, new school scored better than traditional school. In case of maths, traditional school scored better than new school. If you check the box test of equality of covariance matrix, this is the homogeneity of variance, box M. See, it is not significant. It is greater than 0.05, means our homogeneity of variance or covariance assumption holds. So, in case of Anova, that is called homogeneity of variance, that is Levine test. In case of Manova, it is called the box test of equality of covariance. So here, that was in case of Anova, it was equality of variance. Here it is equality of covariance. In case of Anova, it was measured through Levine test. In case of Manova, it is measured through box test. But the interpretation is same. Now, if you check the Levine's test for both the dependent variable, that is English and maths, see, both are greater than 0.05, means not significant, means our homogeneity of variance assumption through Levine's test holds. Now, if you check the multivariate test table, there are 4 statistics: Pillai stress, Wilks lambda, Hotelling stress, and Roy's largest root. We will only interpret Wilks lambda. Why? Wilks lambda is the most popular and most significant of all the 4 test statistics. So Wilks lambda generally we use. So if you check the Wilks lambda, F value is 1409.663, significant, it is highly significant. So again, we can write in the same fashion we were writing for Anova. How we will write here? How we will write? F is, what is the F value? F value for, I am seeing the intersect, you should see the school, because school is the grouping variable. So school Wilks lambda is 4.645. It is less than 0.05. It is significant. So we write like this. F degrees of freedom, again check. What is the degrees of freedom? 2 and 17. So 2, 17 is equal to, what is the result? 4.645. 4.645. P value less than 0.05, means it is significant. So how we will interpret? How we will interpret? This is for See here. If you check this, it will be easier for us to interpret. See here. School, English maths, error, English maths. So what is the English score? English score is 8.803. It is significant. And what is the math scores? Math score is 0.50. It is not significant. Maths is not significant, but English score is significant. So we may write like this. Breakup you can write. This is for school. This is for school. And for English and maths, we can write like this. For English, we will be writing. How we will be write? For English, F. For English, 1 and 18. So F118, 8.803. F118 degrees of freedom, 8.803. And the p-value is less than 0.05. P-value is less than 0.05. For maths, it is 0.500. It is not significant. For maths, again, it is, we will write like this. Same degrees of freedom, 118 is equal to 0.500. P-value is greater than 0.05. So for English, it is significant. But for maths, it is not significant. So the school have a role to play on English and maths, but English, for English test, it is highly significant, but for maths test, it is not significant. Means the school for maths does not have any great role, but for English, it has a great role to play. This is how we interpret. So we will call it up for the day, or if you allow me 5 minutes, then I can show you the Manova repeated measure. Otherwise, I have consumed time. So it's up to you. If you are interested, then I will show you the repeated measure Manova. Otherwise, I will call it off for the day. I think you will be able to handle now, because more or less the pattern is same. So what do you want to do?
Sir, in that also we will go for multivariance only, and then we will interpret.
Yes, for repeated measure, again the sphericity assumption will come into play.
Okay, sir.
Other things remain same.
Sir, I have a question.
Yes.
Every time, whether it's an Anova, univariate Anova with another SPSS dialog box, one box that we have not used till now, that is covariate. How the covariate, what is the significance of covariate, and when its application comes into picture?
See, I have already showed you that in case of sphericity problem, in case of repeated measure case,
Yes.
the factor covariance come into play. Okay, but generally what happens is there are lots of options here in SPSS. Now, sometimes it is inbuilt. Sometimes post hoc you can run in inbuilt SPSS. Sometimes you have to check it separately. So you have to understand that in which condition you will be applying which. So by practice, you can understand that how SPSS is working and what are the conditions which are there in different tests. Some it is inbuilt, some you have to use it separately. Clear?
Okay, sir.
Only by practice you will be able to capture this or master this. Any further question?
Yes, we'll wait for a few more questions. Otherwise, we will end the
Generally
session
what
for
happens
today.
is it is really tough to cover so much within 1.5 hours, 145-minute session. It is really tough for the resource persons, but I have tried my level best to use SPSS. I think SPSS authorities will be happy. I have used in my entire session. So
Yes.
thank you. Now, participants, if you have any question, you may ask me, or otherwise we will call it off for the day.
Sir, could you please say the difference between Manova and Mankova?
Manova and
Mankova.
generally, tell me what do you mean by Manova first. Then I will talk with you regarding Mankova. What is Manova? Manova is clear to you. What is Manova? Then we will go for Mankova. What is Manova to you? How you understand? What is Manova? What is Manova to you first?
If there are two independent variables, then we use Manova.
When there are
Two dependent variables. Two dependent variables.
when there are two dependent variables. Now,
Two or more.
yes, I can't hear you. Can you repeat once more?
If there is more than one dependent variable, we use Manova.
You use Manova. So, what will be? First of all, you understand Anova and Ankova. Then I will talk with you Manova and Mankova. You know what is Anova and Ankova?
Yes,
It
sir.
is just an extension. Mankova is an extension of Ankova. You know what is Anova and what is Ankova?
And co-analysis of covariance, sir.
Yes.
So I need expression regarding covariance, sir. Covariance.
So you have given your own answer. So generally, if it is a case of two independent variables and when you are trying to understand the covariance, you use Mankova. When you have one dependent variable and you are trying to understand the covariance, we call it as Ankova. Clear?
Sir, thank you, sir.
Just if you apply logic, it is easy. Statistics is not very hard, but you have to understand in proper perspective and you have to apply the logic. So, any further doubt? So, Shudipto, can we call it off for the day?
I hope so, sir. So thank you very much from Bharatiya Vidya Institute of Management. I would like to call Professor Atindra Mukherjee for vote of thanks. Atindra, sir. Please unmute yourself, sir.
Am I audible?
Yes, sir. Yes, sir. Please.
Good evening, everyone. This is Professor Atindra Mukherjee from Bharatiya Vidya Bhavan Institute of Management Science, presenting the vote of thanks for today's session. First of all, I would like to express my sincere thanks to today's resource person, Dr. Anirban Sarkar, Professor, Department of Commerce and Management, West Bengal State University, for taking out time from his busy schedule and enlightening us with his lecture. It was truly an enriching session full of information and knowledge. He explained the concepts through various case studies, which I think was very handy and useful for everybody who were present in the session. And last but not the least, I would like to thank all the participants who gave us a patient hearing and made this program successful. Thank you all.
Thank you, Atindra sir.
All the participants. So,
And to all the participants, I am sharing the feedback link. Through the feedback link, we are collecting attendance. So please fill up the feedback form regular basis. Okay. So I am sharing in the chat box. Please fill up the form. So thank you, sir, for accepting our invitation and be there. Thank you very much. And thanks to all the participants for their patience. And we will meet tomorrow, 7 p.m. for the 4th day of our 5 days FDP. Thank you, sir.
thank you.
And good night.
So,
Yes, sir. Please.
so can I leave, Sudipta?
Yes, sir. Yes, sir. Yes, sir. Good night, sir.
Good night. Good night to all the participants.
Good night.